love the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today is chapter 71 in the entire Python and 30 in NumPy. I have to say we have actually finished the distribution and we have actually climbed quite a lot in this NumPy, which is quite a big module. This is the final module piece of the NumPy. It's called functions, and I think we'll be having some 12 or so lectures before we get into quizzes and other things which I'll actually plan on how to do it. And then the entire NumPy module is over. I mean, or in other words, after this 12 series of lectures, the NumPy is over. So we saw how this NumPy actually came, and we also saw how all these distributions came, and the last one being the zibif and how it is actually used in the data analysis and the sensitivity analysis, like if there is a new movie released with the different words like super hit, okay, bad, super bad, just like analysis, okay, sensitivity analysis. So we actually saw that. So we are done and over with all those distributions, and today we are getting into a new thing called U functions, and this is lesson 30 in NumPy. So what are the U functions? The U functions called universal functions that operate on the ND array object. So what are all the universal functions? Red is stop in traffic light universally. Okay, green is go. So anyway you travel across this planet, this is what it is going to be. I don't know what it is going to be in Mars, and I don't know whether, I know they're trying to see whether people can actually live in Mars, but I'm not sure about the other areas. But anywhere in Earth, wherever it is this, you have to follow this universal law. Today, given the fact that genders and roles are changing, I would not comment on that. I'll just leave it to you guys. Anyways, this one is definitely, because some countries have right hand side driving, some countries have left hand side driving, so even there's a change. But universally, red is stop, green is go. So likewise, the same thing applies for a function. So let's actually see. Why use the universal functions? Universal functions, they used to implement vectorization in NumPy, which is way fast than iterating over elements. Speed is the name of the game. Why are we getting to the cloud? Why are we getting to the cluster? What is scalability, reliability, performance, this thing, right? So speed is the name of the game. So that is why you need to use certain things which can actually speeden up this thing. This universal function also provides you broadcasting additional methods like reduce, accumulate, etc., which is very helpful for computation, which we'll be seeing. The universal function takes additional arguments where a Boolean array or condition defining when the operation should take place. Like this is like a trigger. If this thing happens, do this action, else do this action, like an if then else loop, okay, provided a particular trigger happens. Okay, or say suppose you have a tenant. If the tenant pays the rent on the proper time for like 1 year or 2 years, as an appreciation you may keep the same rent or probably reduce it. But if the tenant is not paying for 2 months, then you actually kick out the tenant. So trigger action. So it also, this universal function helps you to actually formulate the same. So D type is defining the type elements. Output array, when the return array value should be copied. So we talked about vectorization. I said about vectorization, it was sounded like a cool thing, but what exactly is this vectorization? Converting iterative statements into vector-based operations is called vectorization. So what is iterative statement? The if then else loops, the do while loops, it's called iterating. Okay, repeating itself is called iterating. The modern CPUs are optimized for such operations, so where it has gone into vectorizations. Okay, so we can actually add list 1 true. So one way of doing it is to iterate over both of the list and then sum of the each elements. Now this x is equal to this, y equals this, and this we know. So this we have already seen that. So let's actually take this and put this here in our Anaconda Jupyter notebooks. Let's actually see what it is. What x, y, z. for I, j in zip of x comma y, I say z, which is this thing, I say append is addition, I plus j or x plus y. This is what I say, and then I say print z, which is basically printing this. So when I actually say this, 1 plus 4 is 5, 7, 9, 11. That is exactly what is given. Taking these two, putting it here in this iterative, okay, where I've taken a for loop or a do while loop. Instead of iterating it time and again, I've just used this append function. I've actually vectorized and I've actually printed. So the amount of time, the CPU time, the fast it has been taken behind the scenes, it's quite fast as compared to the loop. So we are getting into there. So that is why learning this is quite important. The NumPy has a universal function called add, which is the append. It will also produce the same result. So this is a NumPy. I need not even, you can say like, hey, why the hell should am I using this iterative here just because you said vectorization? I can also do an add, right? Yes, the NumPy actually does that. Very, very fine. It actually does that. The same thing I can actually do it here, and I can also do it here. So the NumPy gives me an add. So this is also 5, 7, 9, 11. I hear you. And I can also do the same. When I say print z, it should, but see here. So the name MP is not defined, but that is okay because I have to say import NumPy, because I have to say import NumPy. So that is the only thing which is actually missing. But otherwise, I think it should be fine. See, import NumPy as MP. So this is what is missing. So I can take this, I can put it here, import NumPy as MP. Same thing. I don't even need to use this loop. But there will be some cases where you have to use a loop or any kind of iteration. So that is where this actually comes in handy, the vectorization. All right. I trust you have actually understood this lecture, probably liked it. See how this vectorization and how we can actually make it fast and what the universal function stands for. The next series of lectures is all going to be about the functions, universal functions. There will be a lot of things coming in. So please stay tuned. Like always, I'd like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree, following me to follow my passion. Till we see next time, take care, cheers, and thank you.